Hello, today we're going to be taking a look at Chemistry 1 dump. This is going to be something that can help you while you're taking your chemistry test and also while you're taking the STAAR exam. You should have a blank copy of the periodic table in front of you. As I go along, you should be copying in what I'm doing and paying attention. So let's get started. So the first thing that we're going to talk about is the stair step. So the stair step, as we know, separates the metals from the non-metals on the periodic table. The non-metals are over here, so we'll write NM for non-metals, and the metals are over here. We'll write M for metals. Now, if you ever forget how to identify where the metals and the non-metals are, find something that you know. Okay? Oxygen. We know that oxygen is a non-metal. This is what we breathe. Okay? Gold. We wear gold jewelry, and we know that gold is a metal. So that's one way you can figure out which side of the stair step contains metals and not metals. Along the stair step line, the elements that touch the stair step, those are metalloids, except for aluminum. Aluminum is a metal. Okay? Next, we learned about groups and periods. Okay? Groups are these up and down columns. Next, periods go across. So when we write group and period, the P for group starts the word period. Group, period. All right, so these are our period numbers. There are 7 periods. Periods let you know how many rings an element has. The elements in period 1 have 1 ring. The elements in period 2 have 2 rings. The elements in period 3 has 3 rings, and so forth. Groups. The group numbers tell you how many valence electrons there are. And so we're going to take a look at this number here. We're going to circle this first number before the A. And what these do is they tell you the number of valence electrons. Connect all of these numbers and bring it this way. Remember that valence electrons are the electrons in the outer ring, and that determines how reactive an element is. So the elements in group 1 have 1 valence electrons, and they are very reactive. They are going to react very readily to get more electrons on that outer ring. Okay? Coming along this way, we have group 18, which are stable. They are the noble gases. They have 8 valence electrons. They are stable, which means they can't take any more electrons. They're full. They're stable. They're non-reactive. Okay. I'll draw this line here. And what we're going to do is we're going to draw an arrow this way. And we are going to write increasing reactivity. So what this means is that as you move this way across the periodic table, elements become more reactive. So you have your stable noble gases, which do not react at all, okay? And that's because they have a full outer shell. All of them have 8 valence electrons except for helium. Helium only has 2. That's because it only has 1 ring, and to fill up that first ring, you just need 2 electrons. So these elements are stable or non-reactive, and as you move this way, reactivity increases until you get to group 1, which are your most reactive elements. The next thing that we're going to write over here under group is that groups have same valence and similar properties. So what that means is the elements in group 1 have 1 valence electron, and they have similar properties because they react alike. The elements in group 2 have 2 valence electrons. They react similar to each other because they have the same number of valence electrons. All right, next thing that we're going to do, we are going to draw in an atom up here. So we know that protons are positive, neutrons are neutral, and they are found in the nucleus. Electrons are found out here on the rings, and they follow the 2-8-8 rule. So what that means is 2 electrons can fit on the first ring, up to 8 on the second ring, up to 8 on the third ring. Now that we've drawn the atom and we know the particles, their charges, and their locations, you should also be able to look at any element on the periodic table and figure out how many protons, neutrons, and electrons it would have as a neutral atom. That's where ape man comes in. Atomic number equals protons equals electrons. So if it's a neutral atom, atomic number is 14, which means that it would have 14 protons and 14 electrons. Mass comes from the nucleus, which is your protons plus your neutrons. Protons and neutrons have a mass of 1 AMU each. Remember, electrons are so tiny, we don't count them up in the mass. So anytime you want to figure out the mass, just count up your protons and neutrons. The last part is man, the ape man. So we have the M minus the atomic number equals neutrons. Okay. Mass minus atomic number equals neutrons. Okay. So there you have it. This shows you the parts of the atom, how to figure out protons, neutrons, and electrons, how to figure out where metals, nonmetals, and metalloids are located, what groups and periods tell you, how to figure out valence electrons, how to figure out reactivity, and how many rings each atom has. So make sure that you practice with this, and good job.